Let's do section 11.2, page 552, exercise 25, which reads, an airplane flying in the direction of 20 degrees east of north at 325 miles per hour in still air encounters a 40 mile per hour tailwind acting in the direction of 40 degrees west of north. The airplane maintains its compass heading, but, because of the wind, acquires a new ground speed and direction. What are they? Well, I'm going to start by letting u be the velocity of the airplane all by itself. And I'm going to let v be the velocity of the tailwind. And then I think whenever we're doing problems with vectors, it's really important to draw a picture. So in this case, we're going to label our axes north, south, east, and west. And that u vector, the velocity of my airplane, is going to make an angle of 20 degrees east of north. Now, when you encounter a direction like this, you want to start with the second direction, which is north, and then you're going to move 20 degrees towards the east. So I'm going to start here at north, but I'm going to move 20 degrees to the east, and that's where my vector u is going to be. I'm also going to draw in my vector v, which is going to be 40 degrees west of north. Again, I'm going to start here at north, but now I'm going to go 40 degrees to the west, and that angle will be 40 degrees, and that'll be my vector v. So the new velocity of the plane I'm going to call that w, and that's going to be u plus v. Now, we know that we are only going to be able to add x components to x components and y components to y components because x and y are independent. And that tells me that the x components of my new vectors are going to be the x components of u and v. And the same thing will be true for the y component of my new vector. But to do that math, I'm going to need to know what the x and y components are of u and v. So let's try to find those first. So if we look at u, ux, which is going to be over here, here's going to be my x component, here's going to be my y component. And I know that this angle also has to be 20 degrees because those are alternating interior angles. Then I know that ux is going to have to be the magnitude of u. And in this case, it's going to be times the sine of 20 degrees because ux is opposite of my 20 degrees. So this is going to give me 325 miles per hour times sine 20 degrees, which is going to give me 111.2 miles per hour. And I can do something similar for uy, which I've already drawn in here, and that is going to be the magnitude of u, in this case times the cosine of 20 degrees, because I know that uy is adjacent to my angle. So that's going to be 325 miles per hour times the cosine of 20 degrees, which is going to give me 305.4 miles per hour. And now I can look at v. So my vx component, which is going to point in the negative direction, will go like this. This will be my vy, and I know that this angle here is going to have to be 40 degrees because, again, those are alternating interior angles. So my vx component is going to be negative, and it's going to be the magnitude of v times the sine of 40 degrees. So that's going to be negative 40 miles per hour times the sine of 40, which is going to give me negative 25.7 miles per hour. And Vy is going to be the magnitude of V times the cosine of 40 degrees, because my V component over here is adjacent to my 40 degrees. So that's going to give me 40 miles per hour times the cosine of 40 degrees, which is going to give me 30.6 miles per hour. And now we're ready to find our magnitude and angle for W. So let's start by finding Wx, which is going to be Ux plus Vx. So Ux from up here is 111.2 miles per hour plus Vx, which is negative 25.7 miles per hour. And that's going to give me 85.5 miles per hour. And the y component is going to be Uy plus Vy. And Uy was 305.4 miles per hour. And Vy was 30.6 miles per hour. And this is going to give me approximately 336 miles per hour. And if I want to find the magnitude of W, that's the square root of the sum of the squares of its components. So that's going to give me the square root of 85.5 miles per hour squared plus 336 miles per hour squared. And when I do all of that, I end up with 346.7 miles per hour, which is going to give me that magnitude. And when it's time to find the angle, I think it's important to draw a picture. So here's going to be my vector W, and it's going to have an x component and a y component, and I'm going to choose to find this angle theta right here. So my right angle trigonometry tells me that tangent theta is going to be opposite, which is going to be the y component, which is 336 miles per hour, divided by adjacent, which is going to be the x component, which is going to be 85.5 miles per hour. And that's going to give me, when I plug it all into my calculator, an angle of 75.8 degrees. But in this case, I'm starting in the east direction. So it's going to be 75.8 degrees north of east. Now, all of the other angles in this problem were given with respect to north. So you might want to change that around. And that means that we're going to want this angle here. So if I take 90 minus my theta, I'm going to get 14.2 for this angle here. So it would be 14.2 degrees east of north. Either angle is acceptable, especially if you draw and label a picture.